Hello, and welcome to Instantiating a Class in Python. Okay, now we know what a class is. Now we know how to define a class in Python. It's pretty simple. You may be saying, what do I put in that class? Well, that's all part of the design. That's all part of the requirements and understanding what needs to go into that class. It's all part of object-oriented analysis in a lot of cases. So you'll know what to put in there. You'll know how to build these methods and what kind of properties and what kind of attributes and so on to put in there. But for the most part, for this particular assignment, what we're trying to get used to is how to go about doing it in Python. So don't worry so much about all the things that need to go into it. You'll know that based upon requirements, okay? Now that we have this class, though, we can't use that class. That class is a blueprint. Once again, it's nothing but a bunch of words to the computer until it's instantiated, meaning we create an instance of that class. So we're going to talk about that a little bit. Then we're going to talk about accessing these attributes when it comes to working with the class as we kind of get into it, okay? So an instance of the class or an object. So basically what happens is every time you create an instance of a class, it becomes its own object. That's the term object-oriented, okay? The power of object-oriented is its reuse. We mentioned this before in previous videos. However, it is more than that. You can reuse code differently every time we use it. And once again, so if I create my objects with a lot of flexibility to them, with a lot of different methods and a lot of different properties and a lot of different, what do you want to say, options with these properties and so on. If I do that, each object can be its own thing, and they're literally every instance is mutually exclusive for one another. Once again, in the previous video, I mentioned when you put text boxes onto a form. Again, those are GUI-based classes, but it's the same concept that each text box was unique, and they were mutually exclusive from the other text boxes. They were their own instance. We can do the same thing when it comes to logic like this, which is called business tier type logic. All right, we can create our own instances in doing so. Does that make sense? I hope it does. Once again, I think you'll get used to it. We're just beginning this. If it is a little bit confusing, don't get too upset yet or too frustrated yet. We're just starting it. So we're just kind of rolling into it. And hopefully, as we continue on with the course, you'll get more used to what object-oriented is all about. So every time we state we want to use the class, it becomes an object. The official term is instantiating an object. You'll get used to that term quite a bit. To create instances of a class, you call the class using the class name and pass in whatever arguments its constructor, in this case, underscore, underscore, init, underscore, underscore. This is basically that method, that initialization method. The constructor accepts, okay? So once again, let's look at our employee class that we did. So this is typically how this would look. This is literally a program, a Python program. In this case here, we have defined a class employee. mCount is our class level attribute, okay? These are our instant attributes. So here's what happens. I create an instance called emp1. So the object becomes, it's sort of like declaring a variable. When you sat back and said, I have a variable and it's equal to something. In this case, you're creating an object. Variables are objects. So in this case, you're creating an object, emp1, okay? We'll give it better names as you guys get into it, equals the class, in this case, employee. Okay, and then what we'll do is we're going to pass two parameters to it, Bob and 29. So name and age goes there. emp2, employee, rows and 45. This is a totally different instance. These are two different things. I did not overlay name and age for Bob. So basically, it's another instance. It's a totally different thing. These variables are there, and once I created this new instance here, it added two more variables, if you will, two more instant attributes, if you will, okay, to memory. So now there's 4 instances of those attributes in memory. Does that make sense? So these are two separate things, two mutually exclusive. So we basically, emp2 becomes the class employee, and we pass that there. And now we have 2 instances of this particular class, so 2 objects. That makes sense? I'm going to go back a little bit. Slow down just a little bit. So that's pretty much what we're doing. Now you're saying, oh, where's that display mCount come from? We'll talk about that as we kind of get into the next video and so on. But that's pretty much what we're doing, okay, as I show you how all of this fits together. All right, but this right here, this is outside of the class. As you can see, I'm not indenting. This is now your main routine, if you will, right? The main routine where emp1 equals employee and emp2 equals employee, and they're two separate types of data. And that data, both those pieces of data are now held in memory right now, as just like variables are. All right? Okay. Accessing the attributes. You can access objects attributes using a dot operator with the object. And so in this case here, imp.name we can do, imp1.display employee. Again, an attribute could be a method also. So in this case here, imp1, this is going to display just the name for employee 1. It has nothing to do with employee 2. If I want to access employee 2, this would be imp2. A class level would be accessed using the class name. In this case here, employee count. Okay, if I wanted to access that, that's how I would do that. Okay, so let's go back a little bit and see what I'm saying here. This right here, if I wanted to access it, I would say the word employee because it's a class level variable, count. Okay, and if I wanted to access each individual instant variables, instant attributes, it would be emp1.name. Does that make sense? That's sort of how it is. Again, I'm going to kind of show you how all this comes together, and we'll play around a little bit in the next video as we kind of put it all together to make this thing work. Okay, and you'll have an opportunity to do it too. But let's ask one question. If I sit back and we look at this little definition here, what's happening is this. Every time I instantiate it, this constructor runs. It's going to take these two things and put it into an instant variable. It's also adding one to count. On the second one, emp2, it creates it. It's going to run this definition right here, this particular constructor. Once again, it will put them into two different instant variables for emp2. All right, but it adds one to count. If I actually said display count like I did right here, okay, emp1 display employee, not employee, but count in this case. I'm sorry, I showed you the wrong thing, but display count. What do you think the number would be? If I said total employees are count, and I ran this down here, I just said display count. That's all I need to do is put that there. What do you think the total number of employees are? 1 or 2? It would actually be 2 because it's a class level variable. It's holding that value continuously throughout the entire program, if you will. Does that make sense? Sounds a little familiar? Class level variables versus this. Yeah, maybe from a previous class you heard that word class level variables, which stays in memory throughout. It has nothing to do with the individual instances. It's for the entire class. Does that make sense? Let's go see one work, okay? So with that said, let's all put it together in the next program and the next video. I'll see you there.